it'll be helpful for all the problems, but especially on the new assignment. So let's say some guy's riding a bike around a circular corner at 12.5 meters per second. The radius of the turn is 25 meters. I want to know what's the minimum coefficient of static friction between the tires and the road. Okay. So let's draw a free body diagram here. But the free body diagram, when you're doing centripetal stuff, you have to be a little careful with the free body diagram. So what are the forces acting on the bike? Okay, so there's a normal force pushing up, supporting the bike. There's the weight pushing down. And then if it's going in a turn, what else needs to be happening? There needs to be some centripetal force, doesn't there? Right? Now, what's the mechanism that's delivered? Remember, centripetal force is not a force like friction or normal. I mean, it is kind of like normal force, I guess. It's not a specific force like friction, right, or weight. It is just a category of forces. Centripetal force could be the result of tension if you're swinging a rock around on a string. It could be gravity if there's a satellite in orbit around a planet, for example. Or in this case, what's pushing the bike around towards the center of the circle, allowing it to turn? Friction, yeah, right? Friction is the force. If the road were iced up, the person on the bike couldn't turn because he couldn't generate any friction with the ground, right? So it's the friction that pushes the person towards the center of the circle and allows them to go in the circular path, right? So then the centripetal force, in this case, is just static friction. Why static? Why not kinetic?
Because it doesn't change.
Okay, because it's not sliding. Because the rubber's not sliding along the road, it's rolling, and when it rolls, it doesn't actually slide, right? Okay, so it actually is static. It's slightly modified static, but we'll call it static. So there's our free body diagram, right? So the vertical component, if I want to add up the net force vertically, so the y component of the net force consists of the sum of what forces? So normal force is positive, weight's pushing in the negative direction, so minus mg, and what's that equal to? 0. The person is not accelerating vertically, right? The bike is staying on the ground. So there's our first equation of motion. Second equation of motion, the net force, and in this case, the net force acting horizontally is the centripetal force, isn't it? Right? So I'm going to call that, I guess I could call it the x component of the net force, but what it really is the centripetal force, right? So what is providing the centripetal force? Friction, good. And we know what friction is, right? We'll just jump right to our model for friction. Okay, so it's mu sub s in this case times normal force. And that's equal to, in this case, it's ma, right? But the a is the centripetal acceleration. Okay, make sense? Okay. All right, so then this top equation, if we solve for normal force, we just end up with normal force equals mg. Now, doesn't that kind of make sense? The more you do these, you kind of get a little insight. You start to see that, well, being as this isn't on an incline or anything, right? The gravity's pushing straight down, the weight's pushing straight down, and normal force is pushing straight up. There are no other forces acting, and so they're just equal and opposite, right? So the normal force, the magnitude of normal force is just the weight of the bike and the person, right? So we can substitute that down here, and then we get the equation. What does this equation become? Well, that equation just becomes mu sub s times mg equals m times centripetal acceleration, right? Okay, now what are we trying to do? Solve for this, right? Okay, so I can cancel the m's, I can divide both sides by m, and then I can divide both sides by g, right? And so I end up with mu sub s just equals centripetal acceleration divided by g. But what's our equation for centripetal acceleration? In terms of the stuff that we're given. Looks like we're given a speed, right? And we're given a radius. So if you,
Did we get these?
yeah, it's in the book. It's v squared over r. It's been a while since we talked about it. You guys haven't launched into this much yet, so I wouldn't blame you for not remembering that. So there's centripetal acceleration, right? So I can make that substitution. And I get v squared over r over g. And that's the same thing as g over 1. So if I flip and multiply, does everybody agree? I just get v squared over r times g. Okay, so that's it, right? I could just plug in, so if I plug in numbers here, standard units, I get 12.5 squared, good, over 25 times 9.8. So what is that? Okay, it's gotta be less than that.
46 degrees.
There you go. Okay, so that's the minimum. We need at least that coefficient of static friction to be able to make the turn. We could have more than that, but we can't have, if we have less than that, the bike's gonna slide. Right.
That way, tires will get rubber.
Yep. That's why tires are made of rubber. So they have high coefficient of friction. Yep. Okay. While we're at it, let's take just a quick look. I want to show you these problems. Just take a quick look at these. Okay, what about stuff like this? Okay, steel ball is attached to a string is swung in a horizontal circle at a constant rate. Now, here's the important stuff on this. Okay, look what they tell us. I'm going to make let's make the variables red and we'll make the constants blue. Okay, so they're telling us that the radius is doubled. So it's increased by a factor of 2, but the mass and the velocity are constant, right? So we want to know the period of the ball is changed by a factor of what? Okay, there's only 3 relationships here that you need to know, and they're all interrelated. So we know that, first of all, we know that centripetal acceleration is equal to v squared over r, and that's probably the most basic statement of centripetal acceleration. Okay, you also know that that velocity or speed is just distance over time, right? So there's an easy way to remember this relationship. So speed for uniform circular motion just equals distance over time. Well, how about 1 circumference divided by the time it takes to make a circle, right? To go around one. That's what period is. Right? The period of uniform circular motion is the time to make 1 revolution or rotation, right? So this is just saying distance over time. 1 lap divided by period, which by definition is how long it takes to make a lap, right? So if we just plug that in up here, what we end up getting, and you can do the math, what you end up getting is 4 pi r over t squared. So those 3 equations, that's everything, right? So what about this first one here? Nothing is mentioned up here about acceleration, is it? Right? Look at the quantities that we're comparing. The period of the ball, so we're looking for that, right? And we don't know what that, I'll make that one purple because we don't know what that one is yet. is changed by a factor of what? Well, we're trying to relate period and velocity and radius. Well, period and velocity and radius are related by that equation right there, aren't they? Right? So if the radius is being doubled and the velocity is unchanged, then look what we get here. I don't even need to put these constants in there, do I? Right? I know that v, which is a constant, is proportional to r over t, right? So I have to get v as a constant, so it's not changing. It's changing by a factor of 1, in other words, right? And what we're really looking at here, and we're talking about a proportionality, is by what factors are these quantities increasing or decreasing. We don't need to do any calculations here at all. This is all just what we call in physics. These are just shirt sleeve calculations, meaning we don't have to put any pi's in or any of that stuff. We're just looking at comparing the rates at which these quantities are changing, right? So there's a couple ways we could look at this. We know that this one is changing by a factor of 1, and the radius is doubling, so it's changing by a factor of 2. So what would the time have to be changing by if that fraction is going to be equal to 1? 2, right? Or another way of doing it, you could just swap those two diagonally, because that's a v over 1, right? So I could rewrite this one. Might be a better way to look at it, as period is proportional to r over t, over v, sorry. That's kind of a nice way to do it, because now the constant's on the bottom, so big deal. T and r are going to change at the same rate then, aren't they? If r is doubling, then this is just not changing, so it's changing by a factor of 1. So if that's doubling, then doesn't t have to double also?
Yeah.
You see how we're doing that? Okay? Raise your hand, give me a 1 to 5 on that. 5 meaning I got it down, 1 meaning, what did you just say? 3 meaning we're somewhere in the middle. Okay? Okay?
That's because I was half listening, because I'm trying to figure out my question.
Oh, okay, yeah, so I mean, this might be worth looking at one of these real quick though, because you're gonna get like 3 or 4 of these on the assignment.
Okay, so.
So this one would be what then? 2, I guess, because this rate, so that's 2. Okay, what about the acceleration then? Well, now we go to either one of these, doesn't matter. Take your pick. What if we pick the top one? So we know that v is changing by a factor. It's increasing, no, it's unchanged, right? So this is gonna look like 1 over 1 squared, which is just 1, over r is being doubled. So what's the overall?
1/2.
Yeah, right? So the acceleration must be changing by a factor of 1/2. We could also get it down here. Down here we'd get r is doubled and t is doubled, right? So this one would look like 2 over 2 squared. 1/2, right? The top is doubling, the bottom is quadrupling, so the overall fraction, or excuse me, the overall fraction is being decreased by a factor of 2, right? You multiplied by 1/2.
Yeah, but when I put that in there, it didn't work.
Well, did yours say double?
Yeah.
What?
What?
Let's try it. Let's try it on here. It could be, you know what might have happened? There's one of these was messed up yesterday. Did you start this yesterday?
Sort of this morning.
Oh, then it should be fine. So this one should be, let's just make sure. This one should be
2.
2. This one should be 1/2. And this one should be 1/2. Because the mass, and we'll talk about that in just a second. That's an easy one. Yeah.
Okay.
Yours must say something different.
Oh,
It's got to say something different.
okay, well, you just keep teaching and then.
Now, how about this last one? The last one is just F equals ma, right? Centripetal force, that's all we're doing here. Centripetal force equals mass times centripetal acceleration. If the mass is remaining unchanged, then the force is going to change proportionally with the acceleration, right? Right? Oui. Okay, let's try one more of these. You do this one.
You have 2 minutes.
Okay, that's fine. That's all we need.
I figured it out.
So I have like 30 seconds.
Yeah, right, and it's gonna be different for each one.
So whatever, like 30 seconds.
You do the top one then. You can do it in 10 seconds. The velocity is changed by a factor of 1/3 and the radius remains unchanged. We want to find period. So period, period velocity equals 2 pi r over period. So we said radius is unchanged, velocity is changing by a factor of 1/3. So what does t have to be? 1/3 equals 1 over 3,
By 3.
right?
So,
See what I'm saying? Ignore the constants. We're just talking about proportionality, right?
so T got 3 times bigger.
Yeah, t would have to get 3 times bigger. If the top is staying constant, the bottom would have to increase by a factor of 3 for the overall fraction, right?
These aren't that bad, actually.
No, yeah. See, you get any idea?
Yeah. I like this. But I actually have to.
1, 2, 3, 4, 5, 6. Was anybody gone today? I think everybody's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, everybody's here then.